Welcome to Matrices. Matrix is a rectangular representation of numbers or symbols called elements. The elements are usually enclosed in a bracket as shown below. Unlike in coordinates, we do not use commas to separate the elements. Order of matrices. Elements in a matrix are arranged in rows and columns. Order of a matrix is given as row times column, where the multiplication sign is read as by. In A above, the order is 2 by 2, in B is 1 by 3, and in C it's 3 by 1. This is shown below. The number of rows is given first. Matrix notation. Sometimes a matrix is represented by bold letters. For example, P is given by 4132, Q is equal to 321416. Addition and subtraction of matrices. In addition and subtraction, the corresponding elements are simply added directly. For example, if A is 3, 4, 9, 10 and B is 2, 1, 7, 5, A plus B is given by 3, 4, 9, 10 plus 2, 1, 7, 5 and is equal to 5, 5, 16, 15. Similarly, A minus B is given by 3, 4, 9, 10 minus 2, 1, 7, 5, giving us 1, 3, 2, 5. Note that only matrices of the same order can be added or subtracted. Multiplication of matrices by scalar. If Q is equal to 1325, then 2Q is given by 2 times 1, 2 times 3, 2 times 2 and 2 times 5, which is equal to 2, 6, 4, 10. All the elements are multiplied by the scalar. For example, if D is 9, 15, 6, 3, then a third D is equal to 3, 5, 2, 1. Multiplication of matrix by matrix. Multiplication of matrix times matrix is only possible if the number of rows in the first matrix is equal to the number of columns in the second matrix. That is, if P is 3, 4, 1 and Q is 5, 3, 1, R is 4, 3, 2, 1 and S is 5, 3, 9, 4, 2, 1, P times Q is possible, P times R is not possible, P times S is possible, but Q times R is not possible. Multiplication is done by row times column. For a matrix A is equal to A, B, C, D and B equal to E, F, G, H, A times B will be given as A times E plus B times G, A times F plus B times H, C times E plus D times G, and C times F plus D times H. For example, if P is 2, 3, 1, 2 and Q is 1, 4, 2, 1, then PQ is given as shown below, with the answer being 8, 1, 5, 6. Types of matrices. A matrix is either a row or a column matrix, as shown below. A square matrix. Matrices with equal number of rows and columns are called square matrices as shown below. In general, a square matrix has the order n times n, where n is any number. Identity matrix. A square matrix that does not alter another matrix after multiplication is an identity matrix. For example, 1 0 0 1 and 1 0 0 0 1 0 0 0 1. It is denoted by capital I. Thus, for a matrix A times I is A. For example, P equal to 2 3 1 4 and R equal to that, Pi is given by P times I, which remains P, that is 2 3 1 4, and Ri multiplied by the identity remains R. Null and zero matrix. This is a matrix that has all elements as 0. It is denoted as O. For example, O is equal to 0 0 0 0. For a matrix A times O is equal to 0, A plus O is equal to A, and A minus O is equal to A. Equal matrices. Matrices of same order and corresponding elements are equal. For example, A is equal to 4 9 10 19 and B is 4 9 10 19. A and B are equal matrices. Example, given that P is equal to 2 3 5 1 and Q is 5 2 1 7, calculate PQ. Find S such that PS is equal to P. In our solutions for 1, PQ is equal to P times Q, and we shall end up with 13 25 26 17. In B, take S to be A, B, C, D. Therefore, 2, 3, 5, 1 times A, B, C, D is equal to 2, 3, 5, 1. If we multiply the same way as matrices, we'll end up with simultaneous equations. And if we solve, we will find the solutions as A is 1, B is 0, C is 0, and D is 0. Hence, S is an identity matrix that is 1 0 0 1. Determinant of a 2 by 2 matrix. For a matrix A, B, C, D, A and D form the leading diagonal. B and C form the secondary diagonal. This is illustrated below. The determinant of a matrix A, B, C, D is given by A times D minus B times C. The determinant is always positive. The negative sign is ignored if the results AD minus BC are negative. For example, the determinant of a matrix 5 3 8 9 is given by 5 times 9 minus 8 times 3, which is 24. inverse of a matrix. The inverse of a matrix P is P raised to power negative 1. P times P raised to power negative 1 is equal to I, which is the identity matrix. Finding the inverse of A is equal to A, B, C, D. We follow the following steps. First, find the determinant of A, which is given by AD minus BC. Step number 2, interchange the elements in the leading diagonal and we have the matrix as DBCA. The third step, multiply the element in the secondary diagonal by -1 and we'll end up with a matrix as D minus B minus CA. Divide the results of step 3 by the determinant and we'll end up with 1 over AD minus BC into D minus B minus CA. For example, find the inverse of 3, 4, 2, 6 and 5, 1, 3, 3. The determinant of A is 3 times 6 minus 2 times 4, which is 10. Interchanging the leading diagonal, we have 6, 4, 2, 3. Multiplying the secondary diagonal by -1, we have 6 minus 4 minus 2, 3. And finally, dividing the determinant, we'll end up with 3 over 5, 2 over 5, 1 over 5, 3 over 10. For B, the determinant is 5 times 3 minus 3 times 1, which is 12. Multiplying and interchanging, we are going to have 3 minus 1 minus 3, 5. Then finally dividing by the determinant, we shall end up with 1 over 4 minus 1 over 12 minus 1 over 4 and 5 over 12. Consider the matrix 2, 3, 6, 9. Let's find the inverse. The determinant is 2 times 9 minus 6 times 3, which is equal to 0. If the determinant of a matrix is 0, the matrix has no inverse and is called a singular matrix. Solving simultaneous equations using matrices. Consider 2x plus 3y is equal to 4. 2x plus 4y is equal to 8. The equations can be written as 2, 3, 2, 4 xy is equal to 4, 8. To solve for x and y, we must eliminate the coefficient matrix by multiplying both sides by the inverse of the matrix. Following the described procedures, the inverse of 2, 3, 2, 4 is 2 minus 3 over 2 minus 1, 1. Multiplying both sides by the inverse, we are going to have 2 minus 3 over 2 minus 1, 1. 2, 3, 2, 4 times xy is equal to 2 minus 3 over 2 minus 1, 1 times 4 over 8. When a matrix is multiplied by the inverse, the answer is an identity matrix, and therefore we shall have 1, 0, 0, 1 times xy is equal to minus 4. The identity matrix does not change a matrix, and therefore on the left hand side we will have xy is equal to minus 4, 4, and the solution is x is minus 4 and y is 4. Example 2, we solve for the following simultaneous equation, and we follow the same procedure, and we'll end up with x is plus 17 over 5 and y is minus 1 over 5.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it.